To define percent composition, we use the phrase the percent by mass. And that will make more sense as we go through an example. So we're pretty much just going to go right to an example. We want to, and you guys have done this in lab if you've already done the hydrated copper sulfate lab, we want to calculate the percentage of water in a compound. So what you see here is a hydrated formula. We know it's a hydrated formula because of this big red or big black dot that I'm putting my red cursor on. And then you see this coefficient with water. Typically, when you're figuring out the gram formula mass of a substance, you don't include any coefficients you may find in a chemical equation. This isn't a chemical equation, though. This is a chemical formula for a hydrated compound. So we are going to take into account this 7. So let's see what we would do. So first we need to figure out how many atoms of each of the elements we have. So I'm going to list my elements: zinc, sulfur, and oxygen. And then typically what you would do is add in the oxygens from the water and then pull out hydrogen separately. But I know that I'm going to be calculating the water separately, so I'm also going to calculate that as one thing right here. So now we're just going to multiply how many of each of those atoms we have times its mass. So we have 1 atom of zinc, and we need to multiply that by its mass. So we're going to look in the periodic table to find that. And here's zinc way over here, and its mass is 65.409. And we're going to round that to 2 decimal places. So we're going to use 65.41. And then because that's the identity element, we're just going to get 65.41. Now we're going to do the same thing for sulfur. There's only 1 atom of sulfur. And then here's sulfur right here. And its mass is 32.065. And around that to 2 decimal places, it would end up being 32.07. And then once again, when we do the math, since 1 is the identity element, we get the same number. There are 4 atoms of oxygen, at least in the zinc sulfate part, so I'm going to multiply that by 4. Oxygen is an interesting situation when you look at its mass. It's 15.9994. So we're going to round that to 16. And then do the math there, and it ends up being 64.00. And then water, we actually have 7 molecules of water, so we're going to multiply water's mass times 7. Now we need to actually figure out water's mass. So in parentheses here, I'm going to work this out. In water, we have 2 atoms of hydrogen, so 2 times, and then hydrogen, which is up in this corner, is 1.00794. So when we round that to 2 decimal places, it ends up being 1.01. And then also we need to, maybe I shouldn't put in parentheses there. We are going to add the mass of 1 atom, 1 times the mass of oxygen, which is 16.00. The work that we have in the parentheses, 2 times 1.01 would be 2.02, plus the 16.00 works out to be 18.02. So really what we're going to end up doing is multiplying 7 times 18.02. And that works out to be 126.14. Now to get our total mass, we're going to have to add all those numbers up. And I'm actually adding this one, and this one to this one. So all of them together is going to give our percent of whole. So we'll just add those numbers up. 287.62. Now that gives us our GFM, or our gram formula mass of the zinc sulfate, but we need to figure out the percentage of water in that. So all you're going to do is take the mass of the water, which happens to be just above that total mass. We're actually using an equation that you could find on the back of your reference tables in Table T. I don't think we've used Table T yet, so I'm going to show that to you. So here's Table T, and this is on the very back of your reference tables, and you'll see right here we have an equation for percent composition. What we've just figured out is the mass of the whole, so the GFM of that whole molecule, and we're going to put the mass of the part that we're looking for. So in this case, the mass of the 7 waters, and then just multiply by 100. I'll put that away, and actually that's what we have right here. We have the 126.14, which is our 7 water molecules, and then the mass of the whole here. And it's looking like I'm running out of room. Hopefully I can write in the background here. And I'm just going to multiply that by 100. And what I end up getting, and I'm going to round this to 2 decimal places as well, I'm going to get 43.86%. So the percentage by mass, because we figured this out based on mass, not number of atoms or any of that, based on the mass of each of the different elements in this compound, the mass of water contributes to 43.86% of the mass of the hydrated zinc sulfate. All right, next example. We're going to look for the percent, and it doesn't say percent composition or percent by mass, but when it says percent, and they're not talking about percent error, you can assume that they're asking about percent by mass or percent composition. So we have percent of sodium and sodium chloride. So once again, we need to figure out the total mass of sodium chloride. So I'm going to list my elements and then how many atoms of each we have. And I'm going to multiply that by the mass. So I'm going to whip out my periodic table. Right here is sodium, 22.98977, and I'm going to round that to 2 decimal places. And when I do, I'm going to get 22.99. And then for chlorine, which is over on this side, you see that it is 35.453, and when you round to 2 decimal places, you'll get 35.45. 22.99. And then we add those two together in order to get our GFM. And that is our mass of our whole. Since we're looking for sodium, we're going to put the total mass of the sodium atom. In this case, there aren't multiple. So we put 22.99 divided by 58.44. Multiply the whole thing by 100. And we get 39.34%. So 39.34% of the mass of sodium chloride is due to sodium. The only thing they could do to make this harder, which some of you guys may be thinking, gee, this is pretty easy, is to give you a mass. Say they have 50 grams of sodium chloride, and they want to know in that sample what's the mass of sodium. So you still have to do the first steps that you saw in the previous problem, where you end up with at least this much, the 22.99 over 58.44. That's the proportion of the mass of sodium in the total mass of sodium chloride. So you can do this a couple ways. You can take this proportion and multiply it by the mass they've given you in the problem, or you can finish out the problem getting your percentage, then remembering to move your decimal place back 2 spaces, and you're going to use that decimal 0.3934 and multiply by the 50 grams. The choice is yours. I tend to like to use the proportion, so I'm going to do 22.99 divided by 58.44, and I'm going to multiply that by the mass they've given me in the problem. And I'm going to get 19.67 grams of sodium. You could have also done it using the percent that you just figured out. Just move your decimal place 2 to the left, so you get 0.3934 times the 50 grams, and you'll end up with the exact same number that I got using the proportion. The only reason I prefer the proportion is because most of the time it's not two separate questions like this. They'll say just this question. So you'll have to know you need to do all the steps above, and then because I'm lazy like a lot of chemists, I would stop here at the proportion and set it up like this. So I take my mass of sodium divided by mass of whole and multiply it by the mass they've given me in the problem. And that's it. That's percent composition.